Hello and welcome back. Another conversation in artificial intelligence. Thank you so much for being here. It is an honor and privilege. And today we're going to go into an area that is super hot right now. It's autonomous vehicle, but we're going to do this from a different perspective. We're going to see how new technology are enabling autonomous vehicles to go from where we are today to the next generation. And particularly, we're going to see how artificial intelligence-driven radar, we're going to disrupt this industry by bringing a new technology that it's capable of telling the machines what is really in front of the car, which is not possible today. With us today, we have Eran Dor, who is the founder and CEO at CRadar.AI. Hello, Eran. How are you today?
Hello. Great. How are you?
I am super good and very happy having you here today.
Me too. Thank you for having me.
So, Eran, how did you get involved with AI? You are an electronic engineer and you've been in a bunch of semiconductor companies and some defense when you were back in Israel. How did you end up in AI?
The thing is that when you work on hardware, you very quickly you understand that all the hardware is connected with software, with machine learning, with firmware, and you can't really just not see that or not work with that. There is always, from the hardware and from the RF, there's always a ripple effect, and sometimes it's much bigger than a ripple effect, into whatever the software can do with your hardware, into whatever AI in this case can do with the hardware.
So your work is in the realm of autonomous vehicle. I think before we go into the details, what is the status of the technology in autonomous vehicle? What is possible today and what is not possible in your opinion?
So autonomous vehicles right now use majorly three sensors. One is LiDAR, which is actually a radar with light. One is the cameras, and the third one is radar. Where LiDAR is very accurate, can give distances and can identify objects from a very close range to a long range even. A camera can see colors, which LiDAR and radar cannot. But whenever those visual systems encounter weather that is bad, fog, heavy rain, and all kinds of weird lighting situation, then they leave a gap open where the radar needs to fulfill that. Okay,
when I drive the car, and by the way, here on this interview we have an Italian and an Israeli, both known for driving particularly well, let's say.
Yeah.
But when I drive the car, okay, whatever is the weather, whatever is the condition of the road, I am capable of knowing what's going on around me and making the decisions. Now, why do autonomous cars need so many sensors to work?
Well, when we drive a car, we look around us and we see what's in front of us, but we also use our experience and our intelligence, the human intelligence, not artificial intelligence, to understand what's going around us. And when we see even a part of a bicyclist, for instance, we know to fill that gap and to understand what this is. When we see a picture on the back of a truck, we know it's a picture. We don't regard to it as human beings that are really there. We fill up gaps with our brain and with our capabilities from our experience that these sensors cannot do. Because we are using our eyes to see, it's my own belief, we're kind of biased to using a lot of visual systems on vehicles so that we can mimic what we do with our eyes. But what we're doing when we're driving, we're not using only our eyes, we're using a lot of brain power behind that.
Where do you think we are at with that intelligence? And do you envision that at a certain point that intelligence can get rid of all this first part where, there is all the sensory or not? And if not, why?
I think right now we're still at the pretty much the beginning of actually having enough artificial intelligence to drive a car on the roads. Especially when you're talking about a scenario where it's mixed, where it's autonomous cars with human drivers, because autonomous cars have a lot of trouble in understanding what the human driver is going to do. We can look at a human driver in a car and kind of understand what's the next step that human driver is going to do. Now, with respect to the sensors, I believe that the three sensors, LiDAR, radar, and the camera, they will stay there for a long while. And not one of them will be able to replace the other. But having said this, there's a lot of work still to do, especially in all these special scenarios that we can drive in where autonomous cars cannot really drive in.
So we heard last year that the Tesla ran into a white truck, and the problem there was that the sensors didn't understand that there was a truck because of the white color. What can be done to avoid this?
I don't know exactly. I don't know all the details of that white truck because not all of it was released to the press. But when a truck, for instance, is stationary, then a radar that is available today will not be able to see it because radars just take out anything that's stationary. With our technology, you will be able to see stationary objects as well. What I believe happened is that the cameras were just thinking that this is sunlight that's coming in, and that's why it disregarded it. And that's exactly where radar comes in, because if you have a very high performance and accurate radar, you will be able to see that big thing of metal moving slowly or standing there, or even doing something that is out of the ordinary.
Is also radar capable of detecting what is in there? Like if I have a metal, if I have a tree, if I have a dog, a living object, the material that is composing that object in front of the car.
Yes, so if we had the perfect radar, we could do two additional things to whatever radar can do today. So I'll just recap on what the radar can do today. Radar today can tell you a location of an object, which is XYZ in the area, and it can also tell you the velocity of an object, pretty accurate. But a perfect radar would also be able to see micro Doppler, which is movement within movement of anything that's moving, and identify materials. And when I talk about the movement within movement, is that when a person walks, usually that person also moves his limbs. And this is something that radars today cannot see, at least not to distances that are valuable in, let's say, an urban environment. So if you could, for instance, see a blob 100 meters away and see that blob has 8 limbs, then you would already know these are probably 2 people walking. The same is for material detection. If you can use your very accurate radar to detect that this is a piece of metal, or this is a living object, or this is a tree, then you can do decisions like human beings do. Let's say if a kid runs into the street, but there's a parking vehicle on the side, a human being runs into the parking vehicle because this is only money damage. It's not human life. But if you don't know what material each thing is made of, then you have a real problem with that. So the perfect radar would be able to really give you that advantage, in addition to larger range and also identifying stationary objects.
With the technology, the radar technology that Eran is developing, fundamentally, there's going to be additional information provided to the machine intelligence. One is the nature of the material that composes the obstacle, so you can distinguish between a living object and a metal, and also movement inside movement. For our audience to understand at eye level a little bit of the secret sauce of this technology. Is it another piece of artificial intelligence technology? Is it a piece of a secret semiconductor new material that you're using? What it is that makes it so special?
So the basic technology sits in a synthesizer which is a device that creates the frequency for the radar. And as any synthesizer that creates a frequency, the frequency doesn't come out super clean. It comes out with a noise, with noise around it. Once you have that noise around it, this limits your capabilities of the radar itself. And yes, in machine learning and in all kinds of algorithms, people clean up the noise. But when you do that, you do mostly all kinds of averaging and things like that. But if you have much, much lower noise from the get-go from your hardware piece, then it's, of course, much easier for the algorithms to do things that they couldn't do previously, or to do things that they could do previously in a very limited way, now to the full-blown way, like microdoppler. And for microdoppler, for instance, that's interesting is that the entire information for microdoppler is in the phase of the frequency. When we lower the phase noise of the synthesizer, then we can actually see all these microdoppler movements much better and to a much bigger distance.
And that's basically this for our audience. The microdoppler is the effect that is used to measure movements inside movements. So in other words, if a person is walking, he's moving the hands, is moving the legs, and you want to detect both the movement of the body, but also the movement of the legs and the hands with respect to the body. And that's what's possible today.
Yeah. Yes. Another example for that would be a bicyclist. A bicyclist moves the pedals, and those pedals have a very distinctive movement. And this distinctive movement you can actually really see really well with microdoppler. But with today's radars, you can see that pedaling up to 10, 15 meters, which is not very useful. With our technology, you will be able to see it to 80 or 100 meters, which is very useful in an urban environment.
We were saying that this new generation of radar would allow the autonomous vehicle to work in weather conditions that are more challenging. Why is that?
The electromagnetic rays of the radar are not that influenced by weather like light, for instance. So you can actually see through rain, you can see through snow, you can see through fog. Another advantage is that they drove an SUV through all kinds of muddy conditions, and really had to have a lot of mud on top of the radar so that the radar was unusable. But even with some dirt on it, the radar is still usable. But if you have dirt on your lens of your camera is just useless.
I come from Italy. There is a part of Italy in the northern part where there are lots of people that die every year because of the fog. And basically in the fog, you don't know what's happening. Then there is somebody that stops suddenly and it creates huge mega crashes where people die. So why is technology not there today already?
The entire thing of frequency generation hasn't changed much over the last few decades. Today, there are several technologies, or at least one specific technology, that is getting better and better, and that we have utilized to create our new synthesizer technology that is very, very low noise. 10 years ago, you couldn't do that, at least not cost effectively. You could probably create a synthesizer, frequency synthesizer at that level, but it would cost you $10,000, $12,000 to do that. And that is not feasible for a car. Right now, with our technologies, you can implement it in a chip for a few dollars, or maybe even less than $1. So that's a huge advantage for assisted driving.
Today, basically, not only we have an improvement in the core technology, but we have also an improvement in the cost of producing a piece of equipment that is higher performing, but also relatively cheap and adapt to mass production. What has to be the cost of the radar, in the autonomous vehicle system for being compatible with the current market demand?
The numbers run anywhere from $50 to $150 per radar. If you look at what people are doing today, they're using a short-range radar, long-range radar, mid-range radar, and they are adapting the hardware and the software to each one of them, especially on the antenna side. With our technology, we believe that you can make one radar that can do it all. That specific radar might cost a little bit more, but then you can just put less radars in the car and actually have a cheaper sensor system, so to say. Now, in terms of the economics of radars, they have to fit for assisted driving. And assisted driving means that every mid-size, mid-range car, not luxury cars that cost $100,000 and more, should be able to have at least one or two radars or even three radars in them for a good price that meets the demands of the OEM, which is at around $100 right now.
Do you use any machine learning inside your next generation radar?
So what we do, we just take chipsets of other companies and inject our synthesizer into that, and then we do some work on the machine learning and AI to show the capabilities, to show how you can identify a bicyclist, as I say, how you can identify stationary objects, and to show the bigger range that you can get. We can, with our synthesizer, you can double the range or even quadruple it. We're just showing the examples. We're not building a full-fledged radar.
Do you believe this is going to be part of a product, or they will remain only demonstrative features that you're using right now for demonstrating the value of the solid-state technology?
I believe that all of these will turn into real features and a real product. Maybe a bit improved, a bit enhanced, a bit changed, but all of these are very important things for a car to be able to determine. And if you look at, for instance, at artificial intelligence, when the LiDAR and the camera see a bicyclist, and then they get another confirmation from the radar that there is a bicyclist, then you know much more about your surroundings, and you have another confirmation of whatever you're seeing. You can always try to see that two sensors are kind of seeing the same things. Now, a radar gives you data that is non-visual, and non-visual data is something that's uncorrelated with the data that the LiDAR and the camera see. Camera and LiDAR are actually looking at the same thing, just doing a little bit of different observations on them. But if you get another type of data that is uncorrelated, AI thrives on uncorrelated data just as we do.
So this is a technology that is poised to improve the quality of autonomous driving, but also the safety of these cars and the integrability with human driving pretty much. The obvious question is, when are we going to see these things in the market, and what are the dynamics?
I believe that we will start seeing those more and more in the market within 3 to 5 years, which is quite a long time. But radar is going through a revolution right now. You can see that everywhere you go and everywhere you read. There is many startups dealing with radars. All of them have specific and new IP that has never been used before. The tier ones that are making those radar modules to put in the vehicles are continuously looking for new technology and new ways to enhance their products and to sell those to the automakers. And of course, the automakers, they want the safest and the best vehicles, and they want also an overall experience that is the best. And if you look, for instance, what a radar can do versus visual, the radar creates much less data to identify something with micro Doppler than a camera and a LiDAR creates to identify something. So it saves you, at the end, also on CPU power and then power overall.
So it must be very exciting as as an engineer, research engineer, working in this type of areas. So how do people become somebody like yourself?
Well, you learn a lot. You try to do whatever you do best, and you also have to. I mean, the main thing is you have to love what you're doing. You have to like your field of what you're doing. I mean, when I started college, when I was in college, I just loved RF and everything that had to do with RF. And ever since, for the last 20 years, that's what I've been doing in communication systems mainly, and also in radar systems. And when you like what you're doing, and when you follow the market, and when you are really passionate about it, so you find that weakest link, you solve that problem, and if you find a weak link with a nice and big problem to solve, then you can set up your own company and your own startup to go forward and solve it for everybody, not only for that specific place where you work at.
What are the specifics that you think people should acquire in order to work in this area?
The radar industry, although I'm in the hardware side, I think the most needed people there are going to be the people that are going to deal with the digital signal processing, with the algorithms, and with the machine learning and AI behind that. The truth is that, for every like five hardware engineers, you need half an army of software and AI and these engineers, because that's just so much more demanding and so much more work to do there than in the hardware. And that's just the truth about it. But whatever you do, whatever you want to learn what interests you, because if it interests you, if you like it, you're going to be good at it. If you don't like it, you're not going to be good at it.
Very good, Eran. This is a very good piece of advice. And for those who are listening, all the data scientists, this is a new area of data scientists for this new generation of radar technology that is coming up. And I guess there's going to be a number of situations like this in the semiconductor industry, where there's new devices that's going to be highly integrated with the artificial intelligence component and extracting more information out of these devices. What do you think, Eran?
Well, the exciting thing about what's happening today is that the more the software and the code writing advances, and the more the hardware advances, they get intertwined together. And you cannot really develop one without the other, and they're both have to collaborate and have to work together to get out a good product. You see it everywhere. You see it in the smartphones. You see it in Wi-Fi. You see it in communications. You see it in radar and LiDAR and in camera.
So thank you so much to all the people watching this. If you have questions about this particular interview, please comment below. If you have suggestions, reach out to me or make comments. What we discussed today is how new technology are going to enable autonomous vehicles that are safer and that can work in more complex weather conditions, and also can interact better with the human driver. So, Eran, thank you so much. It's been a pleasure having you here today.
It's been a pleasure. Thank you very much.